Hello, let's continue our advanced Sudoku series with Delirium by Sam Cappleman-Lynes. This is puzzle number 9 of chapter 2 of the Sudokult Gospel document, which you can find in the description. We are almost done with chapter 2, amazingly. I think there's one more puzzle after this. And then we'll be moving on to chapter 3. So, as usual, I know what technique I'm looking for and how it works, but not where it is in this specific puzzle. There is also a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. This is a cool set of givens here. The entire outer border is empty. And then we have a pretty consistent checkerboard pattern interior. So what are we intended to find here is really the first question I want to ask, because I'm not sure what we're going to get from scanning. I guess I could scan to start, because it's helpful even when we go to try to finish the puzzle to have as much information, useful information penciled as we can. But at the same time, okay, well, because there's ones up here, and that's it. This is one of those puzzles that you look at and go, how is this unique? 4 empty houses, completely empty houses. No, 5 empty houses. Delirium's right. Nothing here. Nothing here. I got ones over here. Nothing here. Got ones up here. I found ones. I've limited something to 2 places in 1 box after fully scanning the grid. Okay, so I think we need to be looking for restricted cells. Now the question is it like at these intersections? Let's look. Excuse me. We have 1, 2, 3, 4, 5. We need 6 and 7. We have the 8 and the 9. Okay. So yeah, I think this is the way to go. Let's look at these corners. This sees 1, 2, 3, 4, 5, 6. We need 7 and 8. Can't be 9. Here we have 1, 2, 3, 4, 5, 6, 7. We need 8 and 9. And then here we have the 1, 2, 3, 4, 5. We need 6 and 9. Yeah, I mean, and this is just an XY ring. So let's go over what this means. So let's do the intuitive explanation first. So this has 2 possible values. It can either be a 6 or a 7. Let's look at both worlds. In the case where it's a 7, this becomes an 8, this becomes a 9, and this becomes a 6. Now the thing that we want to notice about that, if I undo real quick, just so I can make sure I get this right, yeah. The thing we want to notice is that this column has a 6 in it, this row has a 7 in it, this column has an 8 in it, and this row has a 9 in it. Right? In these specific cells. Now if I undo that, and instead I make this a 6, then we can go the other way. We go 9, 8, 7. And then, just make sure I get this right. Yeah, okay. This column still has a 6 in it. Yeah, this column still has a 6 in it. This row still has a 7 in it. This column still has an 8 in it, and this row still has a 9 in it. So basically, one of this shared 6, one of them is going to be true. This shared 7, one of those is going to be true. This shared 8, one of those is going to be true, and this shared 9, one of those is going to be true. That's not necessarily going to be that's only true because of the ring that's formed here, right? If we were just taking the rows or the columns by themselves, there's no reason that we couldn't put like a 6 here and then make that 7 and 9. But look what happens over here. These both end up 8, right? Or there's no reason I couldn't put a 7 way over here. That would make this 8 and 6. The row seems like it's fine, but no, look what happens. These are both 9s, right? It's always going to happen because there's only 2 worlds. And in one world, the 6 is here, and in the other world, the 6 is here. Right? Either this is a 6 or it's a 7. And if it's 7, we go 8, 9, 6. So what that's going to do is it's going to eliminate 6s from these 3 cells. It's going to eliminate 7s from these 3 cells. It's going to eliminate 8s from these 3 cells and 9s from these 3 cells. And hopefully that's enough to solve the puzzle, because unless there's more rings or something going on. Who knows what else we're going to have to find. But anyway, that's how the ring works. Now let's look at the rigorous explanation here. So I've got a weak link between these 7s. I've got a weak link between these 8s. I've got a weak link between these 9s. And I've got a weak link between these 6s. Right? A weak link meaning both can't be true. And then the 6 and the 7 here have a strong link. The 7 and the 8 have a strong link. The 8 and the 9 have a strong link, which I'm going to have trouble drawing because I didn't give myself enough space. And then the 6 and the 9 have a strong link. Nice. And so the strong link just means at least one has to be true. Because if this wasn't 6 or 7, then this cell would have no value, right? If a cell that's down to 2 possible candidates, a bi-value cell always has a strong link between those 2 candidates. And so this is an XY ring for that reason. XY meaning we have 2 candidates in each involved cell, and ring meaning it makes a ring. It's a circle. It's a loop. So there we go. And the rigor is telling us, hey, we can start with a strong link and then go all the way around and end on the same candidate with a weak link. And when that happens, that is called a continuous nice loop. Because we start with a strong link, we end with a weak link. So we have from the 6, we have a strong to the 7, a weak to this 7, a strong to this 8, a weak to this 8, a strong to this 9, a weak to this 9, strong to this 6, and a weak back to the original 6. Started with a strong, ended with a weak. When that happens, that's called a continuous nice loop, and it turns all of the weak links into strong links. And so what is the result of that? And I guess I can go over again why that's the case. Because think about what a strong link means. A strong link means one of the 2 is true. So we're going to try to prove that either this 6 is true or this 6 is true, but we can't have both be false, right? If one of them ends up false, the other ends up true. So we can say, okay, well, what happens if this 6 were not true? Well, if this 6 were not true, right? Through this strong link, the 7 becomes true. Then through this weak link, the 7 becomes untrue. This 7 becomes untrue. I guess I could draw this out. So let's just use a different color just to keep things a little sane here. Trying to pick a color that is distinguishable. All right, so we're pretending this 6 is not true. And we're trying to prove that this other 6 becomes true in that case. So the 7 becomes true, which means this 7's not true, which means this 8 is true, which means this 8's not true, which means this 9 is true, which means this 9's not true, which means this 6 is true. And we've proven what we want to prove. Right? Because the strong link tells us the 7 has to be true. The weak link, the weak link tells us that this 7 can't be true. And then that strong link tells us the 8 has to be true, etc. We go all the way around. And this 6 ends up true. There is only, now we just have to prove the other way. We have to prove that it happens both ways. So if this 6 is not true, we're trying to prove that this 6 becomes true. And we go the other way. So this 9 becomes true, which makes this 9 not true, which makes this 8 true, which makes this 8 not true, which makes this 7 true, which makes this 7 not true, and now the 6 is true. And that's what we want to prove. So we have now proven that those 6s have a strong link between them. And that's going to be true of every weak link in this chain. And for every weak link in this chain, you can definitely prove that it becomes a strong link because of the loop. And so now that these are all strong links, what do strong links do? Strong links say that at least one is true. And so a strong link is going to eliminate any candidates that have a weak link to both ends of the strong link. So for example, the 6 in this cell, let me see about this. Okay, the 6 in this cell there is a weak link between this 6 and this 6, and there's a weak link from this 6 to this 6. And so because one of these 2 6s is true, this 6 up here cannot be true. So that is the rigorous explanation. And that you can do that for every single 6 in this column, other than the 2 in the strong link. The 3 7s here, the 3 8s here, the 3 9s there. You can prove that. So that's the rigorous explanation of the continuous nice loop for those who enjoy that. And so that means these are not 6s. So what are they, I guess is the question. Well, the column needs a 2, a 3. Hold on, was there just a hidden 2 in this column? There was, okay. So 2 in this column was already hidden. So that's a 2. We need a 3, and then they can't be 6. So we need a 3, they cannot be 6. We need 7, 8, not 8, and 9. Okay. So this ends up a 3, 7, 9 triple. Okay. And I'm just going to bake this into all the rows. I wonder if there were more hiddens that I missed, but anyway, it doesn't matter at this point. In this row, the 7 gets eliminated from all 3 of these. So they can't be 1, 2, 3. They could be 4, 5, 6, and 8. That's not 4, 6. That's not 8. Okay. And we omitted the 7 on purpose. Hold on. Why was this a triple? It's not a triple. It's 3679 quad in the column. Yeah, and these can't be 6. Okay, good. I think I said it was a triple, and it's not, and I didn't do anything with that, luckily. Anyway, no 8s in these. I do need a 2. Oh, the 2 is placed as well. All these 2s looking in. So we can get this 2. All right, what else do I need in this column? I need a 3, a 4. We have the 5, 6. I do not need a 4. Sorry, we need a 3. We have 4, 5, 6. We need 7. They can't be 8 because of our ring, and we do need a 9. All right, so that cleans up a bit as well. And let's just finish the ring here. So these cannot be a 9, which is a shared digit, but they can't be. So 1, 2, 3, we need a 4, a 5, a 6, and an 8, and they can't be 9. All right, and that cleans up a little bit. Okay. 4 in this row, actually, is right here. So that's not a 4. That places a 4 in this column. Only placed in the box, or the column. 4 is placed over here. Okay, can I do more 2s, by the way? Yes, 2 is placed here. 2 is in one of these 2. 2 is in one of these 2. What about 4s? 4 is in one of these 2. Oh, nope, it's not. 4 is placed. 4 is placed there. 4 is now in one of these 2. I think, yeah, so down here, we need a 4 down here. Okay, it's kind of symmetric. All right, I'm finding this puzzle difficult to scan, to be honest, but let's keep going. So we got the 2s and the 4s. What about 2 in this box? Yes, 2 in this box is placed. Okay. So now I should be down to just this rectangle of 2s, and then I should be down to just this rectangle of 4s. Okay, good. What else should we look at? So we got the 2s and the 4s. What spaces are they occupying that we otherwise would have been interested in using? I wonder if it has to do with these boxes. We can think about it. So the box needs a 3, 5, 6, 7, 8. No. Just no. This box needs a 3, 5, 6, 7, 9. No. Okay, it's not that. Is it the middle box somehow? We do have a 5, 8 pair here, and a 3, 9 pair here. Okay. So what can we do with that? Well, these aren't 5, 8, so maybe that's a good place to start. So what can they be? They can be 1. It can't be 2. Neither of them can be 2. Yeah. Neither of them can be 3. In fact, 3. Yeah, 3 is in the middle here. Can't be 4. Can't be 5, 6. This one can't be 7, but the top can be 7. And then the 8 is part of the 5, 8 pair, and then we need a 9. Okay. So that is pretty limited. And then we have this 3, 9 pair. So what do we need over here? We do need a 1. Which can go on the right only. Of the 2. I just mean of the 2. Obviously 1 can go in here. 2 and then 3. We do, oh no, the 3 is part of the 3, 9 pair. 4, both of them see a 4. 5, this one of the 2 can be 5. 6, this one of the 2 can be 6. And then we need 7 and 8. No, we don't need 7, but we do need an 8. Okay. All right, not getting any naked singles out of this. This 1, 9 and this 1, 8 seem important, but I'm not sure why yet. This middle cell not being a 2, maybe that's interesting. What can this middle cell be? So it can be a 1. Can't be 2, can't be 3 because of the 3, 9 pair. Can't be 4, can't be 5 because of the 5, 8 pair. I think it could, oh, it can't be 6 actually. Can't be 7. Can't be 8 because of the 8, 5, 8. Can't be 9 because of the 3, 9. This makes it a naked single 1. There we go. So now that's an 8 and that's a 9. That's a 1. That's not an 8. That's not a 9. That's not an 8. This is a 7 up here now. We get the 3 here. We get the 9 and the 3 resolved. This resolves our ring. 8, 7, 6, 9. So that's the way it ended up resolving. 5, 8, 5. That's a 7. That's a 6. That's a 6. There we go. Okay. So the naked single 1 in the middle is the thing I was supposed to see. Which makes sense because I had two pairs looking at it. And I went out to the outsides first, but that's okay. I need a 4 and a 5 here. And then I need I'm going to get rid of the 4s. Get rid of these 2s as well. So I need a 2 and what? 2 and 3, it looks like. So do I want to think about this quad? Not really, but I'll think about it anyway. 7's on the left. All right, anyway, we need 6, 7, 8, 9. So let's just fill that out. Okay. That wasn't as exciting as I hoped, but anyway. How about this quad? Oh, how about this pair? That's even better. 3 and 7 are left. Darn. Okay. This triple. We need a 5, 6, and 8. Well, the 8 is placed. The 8's here. And we need 5 and 6. Yeah, that's 5, that's 6. Okay. Over here, we need a 3. Is 3 placed? No. 3, 7, 9. Well, the 7 is placed here. Then we're down to 3, 9. That's 9, that's 3. Okay. What's next? How about this box? We need a 1. We need a 4 and an 8. 1, 4, 8. That's not that exciting. Okay. How about up here? It's 2 pairs. So the box needs a 1, which is up here. The box needs a 5, which goes down here. We need a 6, which goes up here. And then we need a 9, which goes down here. Wonderful. I'm looking vertically to see if I can do anything, but I don't think I can yet. There's going to be something soon. Okay, these 4. We need a 3, 5, 7, 9. Okay, the 5 is placed. 3, 3, 5, 7, 9. So these are 3, 7, 9. Ah, this I didn't see that this saw the 7 and the 9. Okay, so that's a 3. That's 7. That's 3. Oop, doot, 3 in the corner. 2 and 3. That's a 2. We get the 7 and the 9 here. All right, we should be finishing now. 6, 8, 9. Can't be 6, so it's 8, 9, I guess. What else do we need in this box? 5. So the 5 goes here, and then this is 8 or 9, which actually is only 8. So that's 8. That's 9. That makes that 9 and 7. These are a 6, 8 pair now. Come on, resolve. Oh, here we go. 5 and 9. 4 and 5. That's a 4. All right. What do we got? What do we got over here? This box needs a 1, which goes over here. The box needs a 3, which goes here, giving us the 1. 8 and 1, 6 and 8, 6 and 1. And then over here we need 6 and 8. And there we go. We're done. All right. Cool. Neat puzzle, Sam. Just the fact that the border was completely empty and the middle box was completely empty. There was literally no basics to find. I think we got these once. I think I could have found some hiddens in this call. Like I could have found this too. So yeah, there were some hiddens you could find, but they wouldn't have gotten very far. And then very well telegraphed just these 4 corners forming an XY ring. So that did a lot of work. A lot of work. It gave us, what's cool is the consequence was giving us this 3-9 pair and this 5-8 pair, causing the middle digit of the empty box to be a naked single one. And then from there, it just like started resolving everything. So that was awesome. Well, thank you, Sam. Really enjoyed this puzzle. Hope you did as well. And if you did, then why not leave a like, subscribe, and a kind comment below.